problems based on types of relations of kind 2. So, here second kind of types of relations are of equivalence relation, transitive relation, antisymmetric, symmetric and as well as the reflexive. So, based upon these relations we are going to perform few problems in an advanced level. To be an equivalence relation, so here the relation must be of reflexive, symmetric and as well as the transitive. So, here based upon this we are going to perform. So, here a few problems. Then now the problem number 1. So, under the problem number 1, the relation, when we consider the relation as R, then the property is of. So, here the relation is a subset of in a set of sets is not an equivalence relation. So, here we have to prove it. So, the proof starts now, whereas as per the problem, so here we have to prove the condition of the relation when we consider it as R, the condition or the property is of is a subset. So, based upon this property we have to show that the relation that is a subset is not an equivalence one. That is, so here is a subset is not an equivalence, to be a not an equivalence. So, we have to first of all we have to show. So, we have to go through reflexive, symmetric and as well as the transitive. If any one of the out of the three, that is reflexive, transitive and as well as symmetric is not holds good, then the relation is a subset is not said to be called as an equivalence one. Then now the proof starts now. In our proof, let R be the relation with the property or with the formula is a subset. So, here as per problem, so here we have assumed, so here R be the relation with the property is a subset of in a set of sets. Then now we are going to suppose those sets in this particular set as, then in the next logical step, so we are going to consider the relation as the relation R is equals to, so here the sets are of one is x comma y comma z. So, here we assume the sets as one as x, the second one as y and the third one as z. Then now here we are going to deal all the three cases. Then in case number 1, so here I am going to assume, so here let the first set x is equals to the elements as 1 comma 2 and the second set y as 1 comma 2 comma 3 and the third set that is z is equals to 1 comma 2 comma 3 comma 4. Then now we are going to perform the case number 1. So, in our case number 1, so here x is belonging to R. So, here x belongs to R, whereas here, so R is a relation with the property is a subset of. Then now So here x is belonging to R. So here if x belongs to R, then that implies, so here x comma x also belongs to R. So here since the subset, so here the relation is a subset of, so here x is of, the elements of x are of 1 comma 2. So here then we have, so here the elements of x are of 1 comma 2, then the condition is of is a subset of then x. So here again the elements of x are of 1 comma 2. So from this it is clear that, so 1 comma 2 are the elements of the x, then 1 comma 2 are also the elements of x. So 1 comma 2 elements are also present in the second set. So here every set is a subset to itself. Therefore the relation that is a subset of is a reflexive one. So here since every set is a subset to itself, so here hence relation R is a subset of is a reflexive one, or in other words is a reflexive relation. So in this manner, so here we got the is a subset of, the relation is a subset of is a reflexive relation. Since every set is a subset to itself, therefore 1 comma 2 are also present in the second set, therefore x is a subset to x itself. Then now in this manner we got the relation that is a subset of is a reflexive relation. Then now let us go for the second case, that is case number 2.